Duck.
What are interesting?
Ugh. Alright. And we're live. Okay. I think it's been another week. We're going to try out TensorFlow some more today. We're not giving up just yet. We're going to keep at it. But instead of going into the next most complicated tutorial, we're going to step back and actually look at something a little simpler. So instead, we are going to be working on what's called the basic usage page. This will actually teach you sort of how TensorFlow works at the lowest level. So like how you define your graph and then you run it, and how you need to input variables into your graph. And it's a little bit different from other things. 1 second. Okay. So we probably should have done this first, probably even before doing MNIST, but I didn't see it there first. I saw tutorials. I thought that would be the great place to go. But after fiddling around a little bit, I found the right page to go to. So we're going to walk through this. This shouldn't take that long. It shouldn't be that terribly complicated. And since that day, since last week, I've been fiddling more with it. Several people left helpful comments or questions, and I think we've all learned some things. So let us jump right into this basic usage. As I said, it's going to teach us that we represent our computations as graphs. So we're going to write code, and when we execute most of that code, that's just building up our graph. We are not actually executing anything yet. We're not putting in any data, because the data gets executed in what are called sessions. So you start up a session, and then you'll say session.run to execute some piece, to execute your graph. Or, as I believe we'll learn down here, if you have what's called an interactive session, then you can actually execute one small node of the graph. You sort of give it a dummy input or a predefined input, and it will spit out the output. And so that's how you can view inside what's going on. That's with the eval keyword. We're going to learn a little bit about tensors, which is a fancy word for multi-dimensional arrays in this context. I've seen tensors described a lot in like mathematical physics papers and things like that. There may be intricacies that I'm missing when I say this is a multi-dimensional array, but that's okay. Hopefully we'll learn about that. Variables, that's going to be this interior to your computation graph. You'll have little variables that you need to store things. Sort of like you have variables just in code normally or in algebra, but you need to define them explicitly for the graph, not just in Python. And feeds and fetches, I'm pretty sure a feed is what goes into a node, or what we're putting into whatever computation we're doing, and fetches is what we're going to get out. And in fact, to get data into and out of arbitrary operations. So that's exactly what it says. That's pretty reasonable. Yes. I don't want to just read this to people. I want to try to hopefully explain it, and if it's too boring, well, I'm really sorry. Yeah, so we're talking about TensorFlow builds a graph. The graphs are nodes in the graph. So a node is some chunk, some point in the graph, and there's some edge that will connect it to another node. That's the most basic level of what a graph is in the mathematical sense. So our operation, whatever computation we're doing, is the node. The edges represent the input and the output. And all the data in TensorFlow is stored in what it's called tensors. As I said, these are multi-dimensional arrays is basically what it is. So if you've got a two-dimensional array, you've got rows and columns. If you've got a three-dimensional array, you've got rows, columns, and like depth maybe. If you've got an n-dimensional, so an arbitrary number of dimensions, it gets difficult to visualize. In fact, visualizing in 3 dimensions is usually pretty hard to begin with. Maybe you can use a heat map to try to get, so you've got 2 dimensions and then you got a color in each position. And if you want 4 dimensions, you can do that, and you can just flash them by as a quick video. But that's getting out of things. The point is, that's how your array is stored in these tensor objects. And the TensorFlow graph is just a description of these computations, all these nodes and edges that are connected to things. And the session will actually do the computing, and it connects to your devices. So if you've got the CPU version or the GPU version, someone left a helpful comment on how to get the GPU version running. I haven't actually tried that yet, but I hope to at some point, because that would speed up things considerably, I hope. All right. So the computation graph, usually structured into the construction phase. So that's where you define whatever the graph is. You're gonna feel like you're actually doing the computations right there. You'll even be like running code to define the graph. You'll say, aha, yes, I'm defining the first layer of my hidden neural network. It's gonna take all this input. Okay, now I'm gonna define the next layer. And you'll feel like you're running it, but you're not yet. You're just defining what the graph is gonna be. It's just like when you're writing code, you're not actually executing it just yet. And even when you run this code in Python, it doesn't execute any operations until you do that session.run. So that might be a little bit different workflow than you're used to. You might not get the immediate feedback of, oh, let me run this code, error. Instead, you'll build your graph, whatever, and then you'll say, oh, great, now I'm done. Now I just hit go. And then bad things happen. So you can try it a little bit at a time if you want. We'll see what that workflow is like. Building the graph. Okay. Python library has a default graph. So there's sort of a null, empty graph that you start with, and then you start adding things to that. And I guess, however, you can have multiple graphs if you want. And you'll have to look at the graph class documentation to do that. And I could see that making sense. I also wouldn't be surprised if you could sort of incidentally define a graph with nodes that aren't connected at all, so just 2 separate graphs, sort of. I'm not sure what would happen if you would try to run that. I don't know if we'll be exploring that today. Probably just to keep yourself logically sane, you shouldn't do that. If they're really connected in some way, have a node connecting them. If they're really not, have 2 separate graphs. All right, let's just look at some of this code that they're doing. We're going to import TensorFlow as TF. I've opened up a new terminal session here. Oh yeah, you can see that I was trying to do something with SciPy and I failed miserably. We'll just get rid of that. Okay, TensorFlow, we are on pane 1. Yeah, last one used. There we go. Cool. All right, what are we going to do here? We want to create a constant. This is some data in the graph that will never change. It is always 1, or it is always 2, or always whatever it is. And here, we're defining tf.constants. This creates the tensor. That's a constant. In this case, it's 2 elements that are both 3. And so they're calling this a 1x2 matrix. There's 1 row and 2 columns. Conversely, it's possible to have 2 rows and 1 column. You might think that's basically the same thing. For certain matrix algebra, those are not equivalent. Depending how you write your application, it may not matter. If you don't know what to do, probably I would guess you want the 1 row and 2 columns. But we'll get to that when we get to that. Let's go ahead and add this to our code right now. You're wondering, we haven't actually talked about a session yet. So can we even do this? Can we eval? Let's find out. Nope. Cannot evaluate tensor using eval. No default session is registered. Use with default session sesh. So that makes sense. We haven't defined how we're going to do this computation. We're just defining part of the graph, but we have nothing to actually run it yet. So let's do matrix 2 just like they have, and let's do some comments. 1 by 2 matrix, 2 by 1 matrix. Put some lines in between there for clarity. Oh, I have to actually save as basic.py. Oh, sweet syntax highlighting. Well, basic syntax highlighting. I don't know why it's not better. Okay. We're over here. So once you have some tensors in TensorFlow, you can actually multiply them. And so we're going to use this matrix multiply. This is actually why we have this. We've got a 1 by 2 matrix 1, and we're going to multiply that by a 2 by 1 matrix 2. And I believe this is going to give us a single number if it's standard high school algebra. Multiply. Let's define that. No. Let's define matrix 2 first. There we go. Let's define that. So it's this thing. Again, we can't eval this yet because we don't have a session. I could cheat, come over here and say, I want an interactive session. And it says, yes, we've got 4 threads because I've got a quad-core computer. And then I say product.eval. Now I've got a session. Hey, we get a single number, 12. That number should be 3 times 2 plus 3 times 2. Just to show something interesting, if we do it the other way, matrix 2 times matrix 1, we should get a 2 by 2 tensor result. Reverse the order. Just to show you guys the matrix algebra is real. I'm not making it up. Boom, 6, 6, 6, 6, 6. Everything is 2 times 3, 2 times 3, 2 times 3, 2 times 3. Is that right? Yeah. So that's neat. And you can do the eval because we've done this TensorFlow.interactive session. You might be able to do it anyway. I don't know that for 100% sure. Haven't looked that up. But I like to look at things interactively to check my sanity. That's very important to me. Otherwise, I go bonkers. Okay. Now they're saying this fault graph has 3 nodes. Right. A node, we've got this constant thing we define. That's where we define the constant. Define this other constant and do this matrix multiply. Of course, ours actually has 4 nodes because we defined another product. So that's interesting. All right, here they're gonna make their session. I'm not gonna do this. I'm gonna keep my interactive session. Again, because I don't want to go bonkers. So, what do? They just want to run the session. In fact, they're going to run product. This is probably going to be the same as evaluating product. Results. And then they print result, right? Yeah. Print. See if I can spell print. Print result. I'm going to pretend it's a function. Yeah, there we go. So we'll do the same thing for our reverse. Bam! And there we get our 2 by 2 array. Very nice. What is type of result? Is it numpy or is it tensor? It is numpy. Okay, so it gives us back a numpy array. That is nice. That's what I like. Cool. So now we've done some simple things. When you're done with the session, you should session.close. This is most important when you're writing some library that will, or writing some script that will take advantage of TensorFlow. It will open up the session, do a bunch of stuff, and then finish with that session, say. Because you don't want to be hogging those resources when you're not using them. Right now, I'm working interactively, so I don't really care. I need those resources all the time. I'm not running something else on my computer right now. Super good to know. You can use the Python with statement as a session. So just like you can do with open whatever string as f, do stuff with your file, and it will automatically close it for you. This will automatically close your session for you. Now, let's see if I remember at the end of this stream to run session.close. You can make your bets now. We'll find out. All right. And yes, if you have a CPU or you've got the GPU version, TensorFlow will take care of the, all right, he's got this operation at this node, let me translate that to this or that or the other thing. It will call the appropriate code on the appropriate device, and that's what they're saying here. If you want to force a particular device, you say, I really want this to run on the GPU, or I really want this to run on the CPU. That would be good. I wonder, is there a way I can get a device list? tf.device. What does it say? Exactly one argument. TensorFlow using GPUs. Maybe that'll tell me. Because if I could say, yeah, I don't have multiple GPUs, I have one, but it doesn't even know about it. Is this, okay, no, this is a different section. Okay. Logging device placement, config, protocol, you see the following output, manual device placement, use a single GPU in a multi-GPU machine, multiple GPUs. It's not really what I wanted. TensorFlow list devices, CPU, GPU. What does the internet have to tell me? No. I get this every time, TensorFlow, whenever I try to search some TensorFlow stuff. Let me look at this, FAQ. GPU. How are devices named? Supported devices are da, 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 da. Okay, but how do I find out what devices are available? List available devices? Is that a better search? Maybe? Maybe? Da, da, da. Be able to run. How many CPUs? What is this? I understand there's ways to look up if you have the GPU or if you have a CPU, but to see if TensorFlow has access to it is really what I'm trying to sort out. This guy doesn't seem to be running it quite like I imagine. He's using C++, looks like. Or def device for node. If n.type is this, do this. Graph.is device for node n. So he's just doing his matrix multiplies here. Seems a whole bunch of operations aren't supported on the GPU. Right, so some things you can't do on a GPU apparently. That's fine. But I just want to know, what devices do you have? That's what I want to know. For GPU enabled version, install this. For this, do that. Yada, yada, yada. So it'd be nice to know if there was a way to list what's available, for example. But I do not see that. Sorry it's so late, Mika. Yeah, I actually got started a little late. I got just late, get home, getting dinner. But yes, thank you for checking it out later. Get some sleep. All right, so I don't know how to find what devices are available. If I didn't find it in 5 minutes, I can spend time looking for that later. Be a good question to ask Google. Okay, moving on then. So if you knew the device, you could specify it to run on a particular device. And you could have another function to handle, is this a particular type of call that you could do. All right, what are we doing next? Interactive usage. Hey, this is actually what we've been doing. We've been cheating. That's okay. So launch a graph at the session and use session.run method to execute operations. For ease of use in interactive Python environments, just apply Python. Instead, use interactive session class and the tensor.eval and operation.run methods. This avoids having to keep a variable holding the session. Well, isn't that nice? Oh, now I can just, whatever. But you can still use the session. Like, you have a variable with the session. And you can still use that to do the run. I mean, that's what we did up here, right? Yeah. So, maybe there's a specific thing that I'm missing. All right, so let's look at what they do here, just to make sure we understand. They have a variable that they're initializing, to 1 comma 2. It is a 1 by 2 tensor. And then they've got a constant, which is basically the same one that we had. It is matrix 1 right here. This is good old matrix 1. Okay, so we're just gonna say A equals matrix 1. Won't go crazy here. Initialize X using the run method of its initializer op. What the hell does that mean? PC load letter. Maybe we haven't initialized X? Have I misunderstood X? Let's do this. What is X? It's a variable. It's got an eval. What if I do that? Whoa, it doesn't like that. Failed precondition error, attempting to use uninitialized value variable. Interesting. Let's do this. Let's do this. So this is just defining what the variable is going to be, and then we actually initialize it by calling initializer.run. And now I bet I can do x.eval. Yes. So even though here we're saying this is a TensorFlow tensor variable with these values, 1.0, comma 2.0, those values don't actually get assigned until we run this initialization. Because this is a variable, not a constant. So these values could change at some point. So until they're initialized, nothing is actually there. I'm guessing part of this is because if you know a value is constant, you can optimize your graph a little bit. And so that's why they're not that's why they're not auto-initialized to these values right here. And it might be possible that you could initialize it to something else. X.initializer. What can we do with that? Dot inputs name. I just want to know what can we list of tensor objects representing that input. There's no data inputs here. Okay. So let's call this TensorFlow variable. TF variable. Let's call this actually put values in X. There we go. That's literally what initialize means, but that's okay. Okay. So now we have X. We told it to run. In fact, did initializer.run. Because we're doing this interactively, that's why we need to do this, because we're about to use X here. We're about to subtract A from X. I believe this is going to work element-wise. That's a typical thing to do in matrix addition and subtraction. So tf.sub is going to be a predefined function to subtract. Not a big surprise. I wonder what happens if you just say x dot minus a though. It still works. All right, I want to see. They call it sub. All right, that's fine. So we'll run their function tf.sub x minus a. Very simple. And then we say sub. We're going to eval. Yeah. Sub.eval. Boom, and there you get the -2 and -1, which is of course 1 minus 3 is -2, and 2 minus 3 is -1. But let's see if we can do x minus a dot eval directly. So without having to use their funky subroutine. In fact, you can do that. And I bet if we wanted to, we could say this. Oop, there we go. So we can just use the actual subtraction sign and then get the same thing. So you don't have to say tf.sub, which might feel a little counterintuitive, might lead to your code getting lots and lots of things, but that's okay. You run that, you get sub2.eval, boom. And that actually gives you your variable. Cool. They might actually show us that later, I don't know. I just wanted to try that out right now. All right, TensorFlow programs use the tensor data structure. We're going to learn more about tensors. Tensors are the only thing you can pass between nodes of your graph. So everything is a tensor. Even if it's just a scalar value, that just means it's a 1-by-1 tensor. A tensor has a static type, a rank, and a shape. That's interesting. So the static type, so it's a multidimensional array. This is different from a list of lists. In Python, in a list, every index, every position can be an arbitrary object type. So the first one can be a string, the next one can be another list, and then you can have an integer. For example, a string, an integer, and another list. Let's go 1, 2, 3, 4. Make that nice and easy. And that's totally valid. There's nothing wrong with that list. But if you have a multidimensional array for computational efficiency, you define a data type. So you're saying this is float 32, which means use 32 bits to store a decimal number, a float, or a floating point value, as opposed to an integer 0, 1, 2, 3, 4, 5, or -1, -2, whatever. The more bits that you have, the more memory it takes to store that, but the bigger number you can store, the more accuracy you have. If you have 64 bits, that's called double precision. If you have 32 bits, I believe that's called single precision. And there's more math that goes into it, especially for storing floating point numbers that I'm not going to go into. That's beyond the scope of this. The point is, if you have a particular data type, you can only store that. So if you have integers, you can only store integers. You can't store strings, you can't store other lists. But now you can store it in literal memory in your RAM directly, not in a funky Python object. So it's very quick to access and use. So that's the advantage. And it takes up less space. So for computational purposes, that's why that is the way it is. So if you've ever tried to use NumPy and you wanted to do something like this and you got burned, that's why. So they're just letting us know in TensorFlow, tensors have a particular type and a particular shape and a particular rank. I'm gonna have to see, I want to see what that's about. What is the rank in TensorFlow system? Described by a unit of dimensionality known as a rank. Rank is not the same as a matrix rank. Yes, matrix rank is sort of how many of our rows are independent. Tensor rank, sometimes referred to as order or degree or n dimension, is the number of dimensions of the tensor. I would have thought that was the shape. For example, the following tensor, defined as a Python list, has a rank 2. So this is a 3 by 3 tensor. Oh, right. I consider this part of the shape. But this is a 3 by 3. This is a 2-dimensional array. So it has rank 2, they're saying. So degree, n dimension, I don't know. I read those, but they didn't actually go into my brain. They just came into my eyes, went right out my mouth, and back out. Yes, how many dimensions is your array? I think of that as being part of the shape. I guess they disagree. Uses 3 notational conventions to describe the tensor dimensionality, rank, shape, and dimension number. So 0D is a scalar. 1D is a vector. Should be familiar with that. 2D is a matrix. 3D and higher is more complicated. All right, that's interesting. Here's the various data types you can store things in. So if you're wondering, well, if you've got lots of memory, why would you ever use a smaller data type when a larger data type will get you more precision? You might have a really, really, really big array or tensor, and so you need to be careful how much space you use. And so for that, you'll say, all right, I need to use the smallest one I can, or you need really, really fast operations, and so that might ask for you using smaller size. That's usually the kind of thing. So yeah, these is all pretty standard. Oh, what is this? QINT32? 32-bit signed integer used in quantized ops. I don't know what that's about. Also, oh, it's nice. We get complex numbers built in. So real and imaginary. We have Boolean. That's cool. You can have string. This is not going to be as efficient, guaranteed. But it's a nice convenience function for when you need it. Okay. So that was all about tensors. They are n-dimensional arrays with a specific data type that are going to be stored in memory. Variables maintain state across executions of the graph. This is important. If you remember back in I think the first or second video, the MNIST data set, you train the data a little bit at a time with like 50 images at a time. Those variables are persisting. So you figure out what those weights are to build your model, and you tweak them a little bit each time. So what are we going to see? We can look at variables for more details. I think this is okay. So we create a variable. And here we're going to say we're going to start with a scalar value of 0. Oh, we can give it a name. That's nice. Although it's going to be a little confusing when it's got a name here, counter, and it's got a Python variable named state. We'll find out how confusing this is shortly. Variables, yay. That's the state. Boom, we have a state. I bet I can, let's try state.eval. Let's see what happens. Yes, we have not actually initialized it yet. Can I say like state.name? Is that a thing? State.name. Counter, hey, what do you know? I imagine the :0 is either the current value or the default value. Or you can think of it as counter guy. It doesn't look like he's shouting as an emoticon. But well, he looks more excited when I highlight him, I think. Now he's pretty chill. Anyway. Okay, so that was our variable. It's going to be initialized to 0 when we actually run the graph, but it's not yet. This initialize all variables is a shortcut that will probably initialize it. We're going to have a constant. It's going to be a 1, which is called 1 here. Pretty obvious. New value. So we'll create something new by adding state and 1. And I'm going to cheat. I'm just going to use the plus sign. And if that doesn't work, I'm going to kick and scream. Shoot. Got burned. Oh, man. That's what I pasted again without being in insert mode. Got lucky because I started on a no. Boom, 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 boom. Okay, we defined a whole bunch of things. So 1 is a constant. New value is going to be, we're going to add 1 to the state. So that's why they're calling this a counter. We're going to end up calling this add several times. I don't want to use the tf.add. I just want to say state plus 1. There we go. What could be more simple? And update. So this puts state plus 1 into this new value thing. And tf.assign says, okay, put new value into state. I will use tf.assign, although I bet in equals, like a Python assignment, will work just as well. We'll do this their way first, sort of. Okay, we have to initialize the variables, of course. On here, they want us to open up a new session. And it looks like, what are we going to do here? Open up a session. We run our initialization op. Oh, key point. This is defining an operation that will initialize the variables, but running this line only defines it. It does not actually initialize the variables yet, because everything has to happen in this sort of like session run or an eval once we've defined it a session. That's going to be tripping me up a whole lot. That's just a different way of thinking that I'm used to. Okay. So what we do here is we initialize all the variables. We print out the current value of state. State gets initialized as 0, you might recall. And then, I don't know why we say for underscore in range 3. That seems like a terrible idea. I get that they're saying we're not going to use this variable. I would still use I, just so I know. And underscore is a special thing in IPython, and I don't want to screw around with that. Sesh.run and sesh.run state. So you're going to run it 3 times. Note that these are all in the same session. When the third one finishes, then we will close the session. I imagine if we opened a new session, reinitialize all the variables, then we're toast. Actually, I bet if we initialize all the variables, it will reset variable or state or counter, it's got so many different names, to 0. But we can play with that in a second. Let's write our own code here. Really, we just need to run this. We need to initialize. And then we need to run this 3 times. For I in range 3. We'll print, what do they do? Sesh.run state, state.eval. That's just something that's more sensible to me. That's something I want to look at the state. Maybe it's not considered TensorFlow-ish. All right, Ryan range 3, new. Sesh.run, sesh.run update. So I could say eval.update, but we'll do it this way, because now I feel like I want to run the whole graph, right? Sesh.run update. And yeah, we'll print out our state again. Whoop. There we go. So I've defined the initial op already. Now we can do that. Now we should be able to look at state. .eval. It's 0. That's good. Life is good. 1.eval is 1. Again, very good. New value, however. Now I run it. Oh shoot. No, that's fine. Let's run this code. Bang. 1, 2, 3. Look at that. We have successfully counted up numbers. We are very good at this. Okay, so that's kind of interesting. I don't know that I can get away with just saying state equals new value. Let's find out. State equals new value. And I say sesh.run? Can I just say sesh.run with no... Oh, that's very complicated. Let's try that. Let me reinitialize things. State.eval is 0 again. That's good. Oh, no. State equals new value. There we go. And let's run that, see what happens. Run takes at least 2 arguments. Okay, so that's why you don't just use the assignment operator like this. Unless I said state, but that might get confused because I have state here and I have state here. So if I want to reassign some value into an existing thing, into an existing node, perhaps it is better to use tf.assign. Maybe it can tell me. Outputs ref if the assignment is done. Mutable tensor, value a tensor. Validate shape. Interesting. Use locking. Oh, so that could be important if you're doing things in parallel. But I don't know how smart it is about parallelizing your graph. My guess is pretty smart. Okay. Sesh done. Print out eval. Okay. We got the output 0, 1, 2, 3. We're good to go. Typically represent parameters of a statistical model as a set of variables. Yes, anything we're going to change inside the computation, we want to be a variable. Because that's what it means. It's a variable thing. So you store the weights for your neural network as a tensor in the variable. Yes. You store a counter object to keep how many times you've gone through an iteration as a variable. Typical stuff. All right, we're going to learn about fetches now. To fetch the outputs of operations, execute the graph with run and call on a session object and pass in the tensors to retrieve. Oh, interesting. For this example, we fetch the signal node state, but you can fetch multiple tensors. Oh-ho. That's interesting. All right, so we're going to define a bunch of constants, 3, 2, and 5. We're going to add 2 and 5. And then we're going to multiply 3 and 2 plus 3 times 2 plus 5. That's all we're going to do. And then we're going to pull out whatever that final result is, mul, and the intermediate result, intermed. Okay, so I'm going to define these constants just like they do. Nothing too fancy there. That's all normal stuff. But intermed, I'm going to say, is input 2 plus input 3, because I'm a rebel, you know? And mul, we'll call it mul, equals input 1 times intermed. Yeah, I like that. And if I just say sesh.run, and I want to get back mul, comma, intermed, let's find out what happens. And let's find out how bad I've screwed this up. I'm not actually going to put it in a variable. Let's find these. Let's run this. Hey, what do you know? And in fact, if you take 2 plus 5, you do get 7. And if you take 7 times 3, you do get 21. So we've gotten back the correct answers. I do feel like it's a little bit of magic that I just define this. Oh, this is tf.constant, and it knows it goes with a particular session. Or maybe, no, I guess it's attached to the default graph. And the session, when I define it, it probably uses the default graph unless otherwise decided. Where tf.interactive session, can you apply a particular graph to it? Hey, graph equals none, what do you know? So everything uses the default graph by default. If you don't define one, it's all going in one big graph, I think. But if you wanted to keep your things logically separate, you would have to define separate graphs. And I imagine then that, what is it, do you like define a graph as being at the forefront, the active graph, and that's when you add things to it? Like defining this constant doesn't get applied to a particular graph. So that must be just, there must be a way to say this node goes in this graph. And it might just be that a certain graph is at the forefront and considered active. tf.graph.g. All right, I'll worry about that later. So yes, we have gotten the thing that we desired. Interesting. I guess we have a more compact notation here than theirs. Theirs is it almost looks like a list of arrays, whereas ours is just an array. That's interesting. Not a big deal. Again, so that's how you get output. They call this a fetch. This was the key here. We say, I want whatever's in this node and whatever's in this node. You pass the list to sesh.run. And it will turn the crank, run the computation, and then give you back the result. But, you know, getting output's good, but it's also good to have input, and that's what feeds is about. And that'll be the last thing here. And I think that'll be a good place to end. Okay. So what are we doing here? Examples above, introduce computation graphs, storing them in constants, variables. Yep, that's all things we like. TensorFlow also provides a feed mechanism, also known as inputs, for patching a tensor directly into any operation of the graph. So you can send data into any node that is expecting input, is sort of the idea. Doesn't matter what it is. The feed temporarily replaces the output of an operation with a tensor value. So you're going to put in some value, will sort of create a dummy node, and it will turn your value into a tensor value. And how do you put this in? You use the feed dict. I think in one of the comments in one of the videos I had, we used this to use the existing MNIST model to, given a new image, give us what the probabilities are for that image being a particular digit. So that's exactly what we're going to do here. Excuse me. Okay. So one thing that, here we go. Most common use case involves designating specific operations to be feed operation by using tf.placeholder to create them. Oh, I bet you can use this feed dict to replace like any node that's an input to another. That's interesting. We might play with that. We might not. We'll see. Here, however, we just got two placeholders, so those require some kind of input, and we're going to multiply them. We're saying, hey, these are floating point numbers. They're decimal numbers, basically. And that's what we're going to do. And we're going to do session.run. This is the output, the fetch. That's what we want. So that's the value we compute. And we're going to put in, we have to put in as this like tensor or array-like thing. So the dictionary input 1, colon, the value 7, input 2, colon, the value 2, we should get 14. Boom, 14. All right, so let's try that. Go down to the bottom. What we got? Boom, boom, boom. Again, we got a placeholder here, placeholder there. There's output. So if I say sesh.run, I want the output. That's the number I want to get back. And my feed dict equals input 1. What does input 1 equals? I want input 1 to happen to be, let's say 3. That's easy. 3 dot. It will probably be smart. You know what? Let's find out. Let's find out if it's smart. And it automatically casts it or converts it to decimal. What do I want input 2 to be? You know what? Let's say 7. 7 dot. All right, close everything out. Let's see what happens. When we run, it should automatically initialize everything for us. You know what? No, there's nothing to initialize in this particular case because it's all placeholders. Boom, 21. What is 3 times 7? 3 times 7 is 21. Hey, that worked out really well. So that actually worked out just fine. Let's change that up a little bit. We'll say use a constant for one, var for the other. Let's see what happens. So instead of tf.placeholder, no, tf.constant, yes, we will put in a 30 for this, because why not? That's how we use constants, right? Yeah, that's how we use constants. And then tf.variable, finish that off. We'll say 1. It defaults to 1 here. Init op tf.initialize all. This is probably going to happen anyway. So I want to make this actually 2. Oh, I should change the names of these things. Otherwise, I'm going to be a horrible person. 3, 4, 2, 3, 4. All right, we'll see if it yells at me because it doesn't have other inputs. Because I've defined this section here that requires inputs. We'll see if it throws up at me and says, you didn't give me inputs for those, even though when I'm asking for output 2, I don't actually need those. The question is, does it understand that those are separate parts of the graph, I guess. Whoa, doesn't like that, okay. All right, so it wants that to be a, there we go, yeah. It was expecting that to be a float, and it didn't automatically cast that in that case. That's fine. I can deal. Again, now we have a constant and a variable. And so we're going to see if we can substitute for those values even though they're not placeholders. And the answer is yes, we can. So that's cool. That's really good to know. Because that means that you can put in a constant or a variable and do things to it, screw around. But when the time comes, but you can also have like a given default value that you want to actually be what normally happens. So this feed dict thing will let you twiddle with the values and see, like, sort of skip a lot of the computation and say, all right, well, I already did that. What happens if this value is this instead of something else? But normally it's going to be already a constant or already computed. So that's actually super good to see that that worked. I want to see, that should be 0, yeah. 5, whatever. Okay. I think that's good, because if you can use it for a placeholder, you can use it for a constant, you can use it for a variable. That's what you got to do. That's really neat. Okay. I think that is where I'm going to call it today. So thanks everyone for listening in. And I will be back in next week. I don't know if I'll be doing more TensorFlow. That seems to be what people like. People have lots of questions about that. I'm still learning about it. If you have any comments, throw them on there. If I did anything really stupid, let me know. I always like it. I always enjoy seeing that. And you guys have a good night.